Hello physics students, in this video lesson we're going to review conservation of momentum and how it relates to collisions. We'll talk about both hit and bounce collisions and hit and stick collisions. As always, have your notes ready, write down examples, and please reach out if you have any questions. Thanks, have a good day. In this lesson, I'm going to review with you big ideas about impulse and momentum. And so when we take a look at impulse and momentum, the times we're using that is mostly in a ball catch kind of problem, or if an object is stopped over a certain amount of time or distance. Those types of problems are going to be our impulse is related to our change in momentum type of problems, where we have force times time is our impulse, and the change in momentum is the momentum after it minus the momentum at the start, or the final minus the initial. All right, so we're going to take a look at this and expand on it in terms of collisions today. Now, the other big idea we talked about in past lessons was conservation of momentum, where the total momentum before is equal to the total momentum after, and we're just looking at different objects. So the momentum of object A plus the momentum of object B before is equal to the momentum of object A plus the momentum of object B after. A lot of times this is a collision type example where things are colliding together and then they might have different or same velocities at the end, and the transfer of momentum. So when we look at those types of problems, we're going to focus in on this equation. And these are really our two big equations of this chapter. All right, so let's focus in on collisions. And we're either going to have two types of collisions. One where the object will hit and then bounce off so that they continue in different velocities. This is technically called elastic. An elastic collision is one where the velocities of the objects after the collision are different. We call that hit and bounce as a shortcut, but it's really an elastic collision. InElastic is the opposite. It's where something hits and sticks. As you can see here, the football is going to collide with the football player, but then they hopefully will catch it, and so they will have the same velocity after the collision. All right, so those things are important when we differentiate between the two types of collisions. Either hit and bounce, which is elastic, or a hit and stick, which is inelastic. Why this becomes so important is when we look at that conservation of momentum in an elastic collision for a hit and bounce scenario, the velocity final for object A and the velocity final for object B are going to be different. You can think about a pool ball colliding, hitting the other billiard balls, and they're all going to have different velocities after that collision. On the other side, in inelastic collision, the hit and stick scenario, the velocity is actually the same. So when we plug that into our momentum equation, where we have the initial momentum of object A plus the initial momentum of object B is equal to the final momentum of object A and the final momentum of object B, we can actually simplify that equation because we know that the final velocity is the same, so we can just multiply our mass added together times that final velocity is equal to the final momentum. All right, so that's a big kind of idea to think about as you're solving these equations. Hopefully this helps you when you're plugging your numbers in. Might make things go just a little bit faster for you on the math side. As always, please reach out if you have any questions. Thanks, and have a great day.